let's say you have a vector A on a plane. Let's say this is O and P. If we want to understand this vector using coordinate geometry, that means using graphs, right? Remember, in graphs we had x coordinate, y coordinate. So using coordinate system we want to understand vectors. So what we do is we build the coordinate system with O as the reference point. So this would be what? This would be our x-axis. This would be y-axis. So the moment we do this, what happens? We end up with some quantity for the x part of it and y part of it, right? That means P can be now written as x comma y in coordinate system. So you have a vector A on a plane. And this can be written as OP as well. Now remember, this vector, you don't necessarily have to take the initial point of the vector as the origin of the coordinate system. You could have something like this. So you have x, you have y, and you have a vector like this. So let's say this is, now we can't use O. So let's say A, B, and this is O. So you could have something like this as well. Okay. Now to understand it in coordinate system, we build a coordinate system with O as the reference point. Now here O is the origin. Then the point P of OP in the first diagram representing A, vector A, has two coordinates. The set of all vectors in this coordinate system in every direction and every magnitude has a 1:1 correspondence with the set of all points in the plane. What this basically means is that if we always start with O, that means our initial point is O, then every point in this graph would represent a vector. So if we treat vector A as an arbitrary vector, then we can treat vector A as an ordered pair of real numbers x comma y. What this means is, in that coordinate system, every point x comma y can be used to represent a vector. So here x and y, we say, are two parts or components, more appropriately, components of vector A. If I'm going to draw the arrow, I don't need to write vector. So A. Now remember, since we were talking only of normal x and y, but if there are 3 dimensions, instead of 2 dimensions, we have third dimension as well. Then we would have 3 components, x, y, and z. We would require 3 numbers to reach a particular point. So in such a situation, the vector will have to be represented using 3 real numbers. So number of components depends on the number of dimensions. Okay, now if we go back to our previous diagram, right, if we look at this A, then the length or magnitude of this would be what? Simple Pythagoras theorem. Yes. Okay, so magnitude of vector A, so let me just draw it again here. So let us say this is P, and let's say this is vector A. Then we know if we drop a perpendicular to the x-axis, then let's say this is x and this is y. So magnitude of A would be the distance from origin. Since it is a right angle triangle, magnitude of OP, this is O, would be the magnitude of A, which would be is equal to square root of O, let's say this is M, OM square plus PM square. Now magnitude of A can be written like this, or we can just say A is equal to square root of x square plus y square. The direction, see, we have found the magnitude of OP of vector A. Now the other aspect is the direction. So the direction can be found using trigonometry. So let's say there is an angle theta. Cos theta is equal to adjacent side by hypotenuse. So x by the magnitude of A. So which implies that x is equal to magnitude of A cos theta. So we got the x value. Similarly, to get the y value, if you look at this again, we want the opposite side. So which means we require sine. So sine theta is equal to y by, which implies y is equal to magnitude of A sine theta. So if we have to use the Cartesian form of vector, we have to use x and y. Now if we are given a vector, to convert it into x comma y, we have to write it using cos theta comma sin theta. Yes. Now what happens to our addition of vectors A plus B in Cartesian form? What happens to this? Now remember, OA is equal to A, which is equal to, let's say, x1 y1. Similarly, OB is equal to B, which is equal to x2 y2. Now remember, these two are vectors, position vectors. Now that means the result would be what? Let's draw the, let's say this is B, this is A, so this would be C. So OC would be what? OC would be A plus B. Now remember, when we talk of point A, x1 is equal to OM. So M, this is O, right? And let's say this is N and this is, let's say, L, right? So x1 would be OM, y1 would be equal to AM, because here you would write x1 y1, and let's say this is P parallel to MN. Now when it comes to B, x2 is equal to OL and y2 is equal to BL. Try to understand this. Without understanding, don't go forward. So if we look at triangle OLB, we know it is congruent to triangle APC. Why? Because they both are right angled and OB is equal to AC. OB is equal to AC. Why? Because it is a parallelogram, or rather it is part of a parallelogram, opposite sides of a parallelogram, and the triangles are right angles triangles, so RHS. So therefore AP is equal to OL equal to X2. AP would be equal to OL because they are congruent, right? So this side would be equal to this side. So in both the cases it is X2. Suddenly how X2 came? Because if we take OL, it starts from 0, 0. So this is X2. So we can say this is also X2. Okay. CP is equal to BL, which is equal to Y2. CP equal to BL. Now, by looking at the diagram, you may not feel that BL equal to CP, right? So, draw with, I'm just doing it by, hand. You take a paper and draw using scales. Now, ON is equal to what? ON is equal to OM plus ON. Sorry, MN. So ON is equal to OM plus MN. Now MN is equal to AP, right? Because they are parallel lines and between the same two parallel lines. So we can write OM plus AP, which is equal to X1 plus X2. Similarly, CN is equal to CP plus PN. Now PN is equal to AM, right? Parallel lines between parallel lines. So CP is equal to AM. CP is Y2 plus Y1. So which means, remember why we are doing all these things is to figure out C, right? To figure out the coordinates of C. So C coordinates would be ON, CN. So C X1 plus X2, Y2 plus, or we can write it Y1 plus Y2. So OC is equal to X1 plus X2, Y1 plus Y2, which implies A plus B is equal to X1 Y1 plus X2 Y2, which can be written as X1 plus X2 Y1 plus Y2. So similarly, scalar multiplication would be M times X, Y. Let's say X1, Y1. So this can be written as mx1, my1. Now, very, very important is the concept of base units or unit vectors. So when we talk of xy coordinates, it's divided into, yes, each jump in x direction is equal to each other. Similarly, each jump in y direction are also equal. So if we just look at this point and let's call it as I, then its ordered pair would be what? 1, 0, right? So from here to here, what will it be? Again, same. If we treat this point as the origin, then the next one would be 1, 0. So, but how do we distinguish that this is not actually, this is a special type of vector where the magnitude is 1. We put a cap over it. Similarly, in the y direction, a special letter has been allocated for it, has been reserved for it. So j is in the y direction. So this would be 0, 1. So unit vectors along x and y axis are called base vectors also. So which means that two-dimensional vectors can be written as a linear combination of I and j. So if we have a point x, y, we can write it as x, 0 plus 0, y, or x times 1, 0 plus y times 0, 1. And 1, 0 is nothing but I. So we can write it as xi plus yj. Now let's understand this using an example. Let's say vector A is equal to I plus 2j, and another vector is there which is let's say 3i plus 5j. So magnitude of A would be what? Magnitude of A would be 1 square plus 2 square, which is 1 plus 4, which is square root of 5. Similarly, magnitude of B would be 3 square is 9 plus 5 square is 25, which is 34. Now the direction of vector A would be what? Cos theta is equal to adjacent side, which is 1 by hypotenuse. Hypotenuse would be what? Magnitude of A. Now magnitude of A would be what? We know this is 2, this is 1. So Pythagoras theorem, 1 square plus 2 square, that is square root of 5. Yes. So cos theta is equal to 1 by root 5. So theta is equal to what? Is cos inverse of 1 by root 5. Now A plus B would be what? Just add the respective components. So I plus 2j plus 3i plus 5j. So 4i plus 7j. Now what would be the magnitude of the sum? This would be 4i plus 7j, which is equal to what? Square root of 16 plus 49, which is equal to 9 plus 6, 15, 5, 1, 4 plus 1, 5 plus 1, 6. So square root of 65. So 65, 5 1s, 5 3s. What about subtraction? This would be magnitude of I plus 2j minus 3i plus, now this would also become, so let's put it in brackets, minus 3i plus 5j, which would be equal to I plus 2j, we have to put caps, minus 3i minus 5j. So this becomes minus 2i minus 3j. So which would be square root of 4 plus 9, which is square root of 30. What about unit vector along A minus B? That would be nothing but A minus B divided by the magnitude of a minus b. So a minus b would be what? A minus b is minus 2i minus 3j divided by magnitude is square root of 30. So which means we can take minus out and write 2i plus 3j by square root of 30. That would be the unit vector. Vectors is a very important topic which you will use it extensively as you go forward. So make sure you understand this very clearly. That's it for today. Bye for now.